Hello everyone, thanks for being here today at this track. So before diving in the wondrous world of polyfills, I'd like to take some time to introduce myself. I'm Lea Verou, as you can see there 3 times. It's a Greek name. I live in Greece. I'm a front-end developer. I love CSS and JavaScript, but don't worry, I'm not going to start singing now. These are the places you can find me on the web. So many people know me for my CSS research, and they were asking me yesterday if it's going to be a talk about CSS. And I was like, dude, it's a JavaScript conference. I'm not going to speak about CSS. So no, it's not about CSS polyfills. Polyfills are to CSS about what a fork is to sushi. You can use it to eat sushi, but it's not really a very good idea. And it's not meant for that purpose. So what are polyfills? Polyfills is a term coined by Remy Sharp last year, but it caught up really quickly. And it actually comes from this product on the cover. That's a UK product, and it's used in the UK to cover up holes and gaps and cracks in walls. And he thought that it's a proper term for describing what polyfills do in a browser, because that's essentially what they do. They cover up holes and gaps in browser support. His official definition for that was that a polyfill is a piece of code or plugin, for example, Chrome frame could be considered a kind of polyfill, that provides the technology that you, the developer, expect the browser to provide natively. Or as Paul Irish put it, it's a shim that mimics a future API by providing fallback functionality to older browsers. So if that sounds a bit unclear, I'm pretty sure almost all of you have done this thing at some point. This is 3 lines of code, or 5, depending on how you count them, but they essentially have all the elements of a good polyfill. They firstly detect if the feature is present, is stream available in strings, and if it's not, they go ahead and implement the feature. And this is a very simple feature, so 1 line is enough. And then after that polyfill is included, the end developer can use it as if it was provided natively. And they can do that thing without being aware that the polyfill actually exists. And that's one of the best advantages of polyfills. You don't have to learn a new API. For example, jQuery is a script that helps us do some tasks in which support is a bit flaky. For example, old IE uses attach event, modern browsers use add event listener, and jQuery covers up this inconsistency. But before using it, you have to learn a new API. It has a whole documentation which you have to learn before you're able to take advantage of it. Polyfills are not that. jQuery is not a polyfill, it's an API wrapper. With polyfills, you don't need to learn anything new, just a spec. And then after a polyfill is included, you can move on, use the spec, as if that functionality was provided natively. And after some years pass, you can just remove the polyfill, and your code still works. There's no dependency on the polyfill. It's just there to bridge the gap between today and the specs. Because sometimes we have amazing, innovative specs that just aren't supported yet, and we want to use them. That's what polyfills are for. So how can you make your own polyfill? Like we saw in that very simple example of trim, there are 3 basic steps. The first step is feature detection. Is this feature already present? Because if it is, we don't need to do anything. We just use the native implementation. If the native implementation is buggy and we need to fix it somehow, that's not really a polyfill. If it's not present, we go to the second step, which is implementation. This is the most clever part, the most tricky part, where you actually have to think of a way to emulate the functionality that's missing. In some cases, it's simple, like in the new ECMAScript methods for strings and arrays. These are the simplest polyfills. In some cases, it's very tricky, like, for example, in CSS polyfills. These are the hardest of all. And after you're done with your code, and you've implemented the feature, the third part is distribution. You have your amazing code, you're proud of it, but other people need to be able to find it and use it. And you need to publish it somewhere, and in a format that's easy for them to use. And you need to actually let people know by including it in the different lists of polyfills that are available. So let's talk a bit about the first part, that's feature detection. I think this is one of the most important parts of polyfills, because if you do that right, you save on lots of performance. If the feature is already present and you move ahead and implement it again, that's a waste. You don't need that waste. You need to actually rely on the feature if it is there. So the two main strategies we use when feature detecting are A, check if something exists. This is the simplest feature detection method. You just check if an API is there, if a property is there, if a function is there, and if it is, you assume that the feature is present. This is much better for performance, because you just check existence of a property, and it's much, much simpler code. Usually it's just one line, but sometimes it doesn't work. Sometimes there are false positives, or sometimes it's just not possible to detect a feature by detecting if something exists. Which brings us to the second core idea, trying something and then trying to check if it worked. That's much more reliable because you actually check the functionality. You don't assume that just because it's there, it works. But it's also much more verbose code. It's much bigger and it's much slower than just checking if something is there. But sometimes it's the only way. And the third method is a combination of the previous two. You first try something, and then you check, did it actually work? Was something created? So let's try and see how we can detect a few common CSS, HTML, and JavaScript features that we commonly need. The first way, which uses the first core idea, checking if something exists, is checking about JavaScript API support. Like, for example, is local storage on window? Is geolocation in the navigator object? Or is query selector in document? As you can see, that's really easy, really small. We just use one line of code for every API. Checking if CSS properties are supported is about as straightforward. We just create a dummy element, and we check if the property is in the style object. In actual cases, you shouldn't create a new element every time. I'm just creating a new element here just to make it simpler, but in actual use cases, you should cache it, because it's not really a good idea to just create one every time this function is called. Or maybe you should also cache the results, because if it's supported, it will always be supported. Another method of checking whether CSS properties are supported is by using the second core idea, which is especially useful if you want to check multiple versions of that property, like multiple prefixes. So you can still follow the previous method, but you will need to camel case your property, and you will need to create two camel case versions of your property, because, for example, border radius that's without a prefix is camel cased to border radius without, and the first B is lowercase. Most border radius is camel cased with a capital M, and then the B is also uppercase. So in this method, we iterate over all the prefixes, we get the prefixed version of the property, and then we set the CSS text of the dummy element to a declaration that uses that property. And because inherit is supported by every CSS property, it should get accepted. If the property is supported, it should accept inherit. So then we try to get the value of that property, and if there's a value, we return that version of the property, because we know that property is supported. If none of these prefixed properties are supported, then in this case we return undefined, and if that function was more correct, it should return null. Checking CSS values requires a bit of a test. There's nothing we can check existence for, so we actually need to apply the property. We just choose any RGBA value, it would work. And actually that method is not just for RGBA, it applies for any kind of CSS property, for calc, for HSLA, for the element function, anything. So you just choose one value that uses this feature, and then you check, was there an error? Did the property keep its value? Because browsers just ditch anything in CSS that doesn't work. If you provide an invalid property, it gets dropped. If you provide an invalid value, it gets dropped. So if it actually kept that value, it means it's supported. CSS selectors are also a bit tricky. You need to create a new style element. You just create a simple rule by using that selector. It's an empty rule. It doesn't need to contain any declarations, just as long as it uses the selector. And we append it to the document, because otherwise, if it's just in the DOM hyperspace, it won't get applied. So then we check, was it a rule created? In this case, I actually check if there's a first CSS rule. You could just check the length of CSS rules. It's the same thing. And we clean up after ourselves, but by removing the element, we don't want to leave it in the document and mess up with the end user's code. And we return the result, if it was there or not. Detecting HTML elements is really hard to do in a generic way. This could be a very optimistic thought, because if you read the DOM specification, it says that every element that's not supported should inherit from the HTML unknown element interface. However, browsers aren't expected to expose these interfaces. It's not required, as long as they use them internally. And also, some browsers don't even follow the spec, and they don't use that at all. In some browsers, unknown elements inherit from the HTML element interface. It's really inconsistent, so we can't do that. It's nice, but it won't work. So what we have to do instead is check for known properties or known methods. Are they present in a new instance of the element? So it's a bit hacky, because we don't know if they actually work, but it gets the job done. It works. It does what we do in most cases. So, for example, if we want to check canvas support, we check if the getContext method is there. Or if we want to check if video is supported, we check the play method. If we want it to be a bit more accurate, we could actually check if it's a function and not just a property. HTML attributes are usually pretty straightforward. Of course, there are caveats to that, which we'll see afterwards. But in the general case, you just check if the getter is present, because browsers assign a getter to every attribute that they support. If they support the placeholder attribute on inputs, they also make a placeholder getter and setter. Or if they support multiple file inputs, they create a multiple accessor. So we can just check if that's present. It won't have a value, so checking if input dot multiple has a true the value won't work. But it will be present, it will be defined. And attribute values are about the same as CSS values. You just set that value, and you check if the browser actually kept it. For example, in this case, type is a supported attribute on inputs. Every browser supports it, but some values aren't really supported. For example, the number type, which is used to create a spinner. Some browsers don't support that yet, like Firefox or IE. So we set the type to a number, and then we check if the browser actually kept that. Because if it doesn't, it usually reverts back to the text value, which is the default. For events, we can do something similar. At least for events that have an accessor like on something, for example, on mouse center, we can set them to a very simple function like return, nothing, which does nothing, and then check, was there a function actually created on that element? If a function was created, it means it's supported. If nothing is there, it means it's not. Unfortunately, there's no way to detect events like DOM content loaded or mutation events. We don't have a way for that. We have to detect something else that we know that if it's present, these events are also present. For mutation events, we can actually change the DOM and see if they got fired, but it's much more messy than that. And of course, even the examples I showed aren't always that simple. There are browser bugs in everything. So, for example, we checked if local storage is supported by checking if it's present on the window object. But in Firefox 3.6, accessing local storage throws an error. So you also need to account for that. Or, for example, Opera doesn't support pointer events on HTML elements, but it still has them in the style object because it supports them in SVG. So we should, before actually deciding on a feature detection code, we should really test in lots and lots of browsers to see if it actually works. Or maybe check the modernizer source to see how they did it, because they need to test in many, many browsers to develop their framework. And of course, there are some features that nobody can detect so far, the undetectables. Some features just, you can't do anything about them. Even Modernizer can't detect them. Pointer events in Opera used to be one of them, because it had a false positive, but now some clever guy, whose name I forget, actually came up with a detection method. He's setting the property, and then he's checking the computed style to see if it got applied. So now we can detect pointer events, and the code isn't that big. But there are many other properties that, and features that can't be detected currently. Maybe you can think of a way. We need that kind of thought. We need people to come up with new ways to detect features. Just because they are on that list doesn't mean they can't be detected. It just means we're not clever enough yet. Maybe you are. So after we're done with feature detection, we're going to the interesting part, which is implementation, actually making the stuff work. The first rule I think every polyfill should follow is following the spec. Not that kind of follow. Actually being faithful to the spec and doing and fulfilling the expectations that people have. There's no use if you're making a polyfill that behaves in a way that you think is better, but it's not what's expected. It will be inconsistent with native implementations. It will be inconsistent with what people have learned. It won't really be a polyfill. It will be an API wrapper masquerading as a polyfill. But, however, as much as it's important to follow the spec, you should also know when to stop, because you don't want your polyfill to end up like this fine lady. You don't want your polyfill to be cluttered. For example, I fell into this trap. When I created a polyfill for the HTML5 progress element, I wanted it to be as correct as possible. I wanted it to respond to property changes and attribute changes, and I wanted the CSS to be super flexible. I wanted to make the best progress polyfill. And I ended up with some code that's 200 lines just to support progress bars. Who will want to use 200 lines just to be able to use the HTML5 progress bars? Your polyfills need to be small so that people will want to include them without introducing an overhead. Because even when they're not executed because the browser already supports the feature, usually they get downloaded, and we don't want to add that much bandwidth. Of course, there are script loaders that only conditionally load polyfills, but in the general case, they're just included along with any other script. A case that's quite tempting to go overboard is a polyfill for document head. How many of you actually have used document head? It's the same thing as document body, but it refers to the head element. It's an HTML5 thing, and it seems that it's really easy to create a polyfill for it. You just check if document head has a value, and if it doesn't, you just assign the first head element to it. But however, there's a big problem in that, and I'm pretty sure some of you have already started seeing it. If your document only has one frame, that's fine. It will work. But if you have multiple frames and you try to actually use that in the other frame, It won't. You will get a type error. Yes, it breaks expectations, but what's the alternative? What would you do to avoid this? The only solution is to hijack every frame in the document, monitor when frames get added, and also fix the document head for them as well. And sometimes windows get opened with window open, so we should replace the window open method and fix that too. I mean, it gets really messy. We don't want that. That's fine. That two-line polyfill is what most people want. They don't want a huge script that's super intrusive and easy to break, just for document head. After all, instead of doing that, they'll just assign the head element to a variable and get it over with. The second rule I think most polyfills should follow is not being intrusive. Like I said, polyfills should follow expectations. And the expectations aren't that you hijack your host document with irrelevant crap. Try not to replace the target element with another, for example. Even if you're super careful and you copy all properties and all attributes and everything, at the very least you'll wipe out all event listeners. And it's really hard for the end user to work with that. Also, try not to manipulate unrelated elements like the body. It might be tempting to add a class to the body to use it in your CSS if your polyfill comes with a CSS, like HTML polyfills, for example. It might be tempting to add a class to the body which corresponds to whether that feature is supported or not. But you should try to find another way to do it, because the host document might actually depend on how many classes the body has. They might have a selector in their CSS about the body not having a class, or if the body having only one class, or something like that, and that will break. And they'll be wondering, why did it break? And they'll find out it's your polyfill, and they won't like it much. Adding extra elements sometimes is inevitable, but you should try to be as conservative as possible. For example, if you're making an HTML polyfill, try to take advantage of the pseudo elements instead of adding new elements to the DOM that break existing selectors that are already in the host document. For example, especially now with CSS3 selectors, we have many CSS rules that depend on the place an element has in the document, on its index among its siblings, on how many elements something has. So you're breaking this if you add extra elements. Try to avoid it. Also, manipulating existing attributes is sometimes the only way, but try to avoid that too. Like, for example, going through the elements you care about and changing their IDs or adding IDs or stuff like that. So you have to do it sometimes, but it breaks expectations for the host document, so try to avoid it. I guess I don't need to tell you that you should try not to pollute the global namespace. You probably already know it, but I had to add it. And also, that's quite obvious too, but sometimes it breaks. Try not to add leaky CSS. Like, for example, you should namespace your CSS to only apply to what you add, to what you target. Don't add CSS like, for example, an element selector that would leak in other elements and not just to the target of your polyfill. And of course, all these are just guidelines, rules of thumb. In most cases, you will need to break at least one of them in most polyfills, at least in most HTML polyfills. But just try to only do them if you really, really have to. Also, remember when we said at the beginning that one of the biggest advantages of polyfills is that you will be able to remove them after a certain point, maybe after some months, maybe after some years, when support gets better, and you don't need that anymore because the browsers that don't support that feature are really old and nobody uses them anymore, so you don't want the overhead. So you should be able to remove that polyfill, and your code still works without the polyfill in browsers that support this feature. So you shouldn't require from the end user of your polyfill to do stuff like this. Feature detection belongs in your polyfill. gathering on the elements and fixing them also depends on your polyfill, belongs to your polyfill. It might sound obvious, but it's really surprising how many people don't follow that. They make a function that implements some functionality, and then they're like, yeah, use that function on any element you want to fix. And they don't actually do that. They don't actually do anything except defining that function. So to use their polyfill, you have to actually add JavaScript code, get all these elements yourself, and apply that function to them. So afterwards, when the time comes to remove the polyfill, your code will break. For example, in this case, it calls the init method of a details object. When the polyfill gets removed, this will throw an error. There's no details element defined. So that's not how polyfill should work. Also, your polyfill will be applied in many cases, in many different cases. In many times, the assumptions you make will be wrong. Many times, we tend to make assumptions to make our job easier, but those assumptions don't really apply to any document. And sometimes we know that, and we just choose to make these assumptions, and some other times, we just didn't think of that. And if you actually have to make an assumption for your polyfill to work, because maybe otherwise your code will be 10 times as big, that's fine. But you should at least know that you're making this assumption. It should be a known unknown. So, attributes and properties will change. There will be other scripts on that page. It won't be just yours, and those scripts will actually change, might actually change attributes and properties. Also, new elements might get added, maybe via Ajax, or maybe they'll get created by some other script. But the thing is, if you make a polyfill, for example, for the HTML5 details element, nothing guarantees that there will be as many details elements when the document is closed as the ones that were there when it was created. CSS can be very different from the one you tried. You might have been making some assumptions, and certain kind of host CSS will break them. And there might not even be a DOM. That might sound weird, and you might be thinking about cases like Node.js, for example, but even in client-side JavaScript, there's not always a DOM. For example, in web workers, your code might need to run in a web worker if it's actually a polyfill that applies to something like that. So you shouldn't depend in a DOM being present. And you might be thinking now, why would I depend on a DOM if my polyfill has nothing to do with a DOM and it can even run in a web worker? For example, if your polyfill needs to resolve URLs and get the separate parts, one way is to parse the URL yourself and return and split it into parts like the host name, the path, the query string, and everything. But another way would be to create a dummy A element and set its href to that URL and then get the properties from there, which might sound quite clever at the time, but it will break when there's no DOM present, even though breaking URLs into parts isn't something that needs to depend on a DOM. And also, you shouldn't even depend on HTML. It might not be HTML. Your polyfill might need to run in an SVG document or in an XML document, and it should still not break. Of course, some of these are edge cases, and maybe you want to make the decision not to support them because it will make your code base huge and you will fall into the trap I fell with the progress element, with the progress polyfill. But you should know that you're making these assumptions, and preferably you should state them in the description of your polyfill so people know them and they won't spend time debugging something that isn't supposed to work in their case. So the first thing, responding to attribute changes, this only applies to HTML polyfills. How can we actually do stuff when attributes change? We have two tools for this. First is mutation events, which are events that get fired when the DOM tree changes, when an attribute gets removed, when an attribute changes, when a new element gets added. The problem with those are they're deprecated now, and there's no alternative. in the standard. They're preparing something, but it's not even in the spec. There's not even a spec yet, and of course, no browser supports it. So for the time being, even though they're deprecated, they're the only thing we can use. And in old IE, there's also this horrible proprietary property change event, which is kind of horrible, like all Microsoft proprietary things, but sometimes it's the only way. And in polyfills, it's the goal that counts, actually filling in the gap. Because eventually it will get removed. Polyfills, by nature, are temporary. So do what you gotta do. For example, Paul Backhouse created an amazing polyfill for CSS transforms and IE. And he used that, and that's actually how I learned about the property change event. He's using that to convert CSS transitions to the matrix filter that IE uses. And that allows us to make CSS polyfills in IE that they can even respond to changes, which is amazing. We can't do that in other browsers. CSS polyfills are a pain in the ass. But in IE, we can, with that thing. So about mutation events. An example of a mutation event is DOM attribute modified, and that's one of the two you're going to use more frequently. It gets fired when an attribute changes, and we can get the old value from it, the new value, and the attribute name. Also, mutation events bubble, so we can just register an event handler in the document, and then monitor all DOM attribute modified events. And if they're of the kind that interests us, we do stuff. If not, we don't do anything. For example, in this case, assume this is a part of a placeholder polyfill. It tests if the node where the attribute got changed is an input node, and then if the attribute that got changed is a placeholder attribute, because then we need to update the placeholder, or if it's a value, because, for example, if we didn't have a value and now we do, we need to make the placeholder vanish. So if that's the case, we call our function in our polyfill, and we update the node. We don't even need to pass the new and the old values in this case, because the only thing we need is the node in this case. The second thing that our polyfill should try to be responsive is properties. Things are a bit better in this one, because we have accessors. Like you might have heard them as getters and setters. These are pretty standard. We also have on property change for old IE. Since old IE treats properties as attributes, that event works in both. And if your polyfill is only to fill in Firefox-specific functionality, then you also have this amazing method that's supported only in Mozilla. It's proprietary, but it's so amazing. I think it should be added to the spec, and every browser should implement it. Instead of accessors make you replace the property with an accessor, a getter and a setter, or just one of the two. Object watch doesn't replace the property, it just watches it. And it fires a callback when it actually changes, which is exactly what we want in polyfills. We don't really want to replace the property, it's a hack, but it's the only thing we have. We actually just want to monitor changes, watch changes, and have something that's the equivalent of an event when the property gets changed. And Object Watch is exactly what we want. But it's only for Firefox. So let's focus a bit on accessors. The standard syntax is the one presented here. We use the define property method in the object constructor. As you probably know, all the new ECMAScript 5 functions and objects are just added on the object constructor instead of specific instances, even though it would be more convenient so that they don't break backwards compatibility when we make polyfills for them. So we have define property. It accepts a get and the set property in the parameter, and we make some callbacks for them, which get fired when somebody attempts to set that property. So this property essentially functions like a property, but actually it's more like a function. For example, in this case, we define a getter and a setter for placeholder. So when somebody tries to get the placeholder value through the getter, we actually invoke this function and return the attribute value, because it's the same in this case. In some other cases, you might want to do some math, because the getter should return a number and the attribute always returns strings. But in this case, it's the same. And when it's set, we invoke a function of our polyfill that updates the placeholder. And also, to match the native implementation of placeholder, we make this accessor enumerable and configurable, which essentially mean that enumerable is that when people use this object on foreign loops, it will be present, unlike some other properties that don't get enumerated. And configurable means that we should be able to replace it with something else if we don't want these accessors anymore. I kind of disagree with it being configurable, but that's how the native implementation works. And like we said, you should follow the spec. You shouldn't break expectations. So this standard syntax of accessors is supported by IE8, Firefox 4, Chrome, Safari 5, and Opera 12, and of course, browsers after those. So what can we do with older browsers? Some of them are really, Opera 12 isn't even released yet. And some of them are quite recent, like Safari 5 is still kind of recent. There is an older syntax for getters and setters, which works in many more browsers, in many older browsers. This was before ECMAScript 5 was published. It was the first syntax we had, and I'm so glad we didn't actually do that, and the ECMAScript 5 way is so much better. This actually only allows us to set a getter and a setter. We can't control whether it's enumerable or whether it's configurable or anything. But in this case, it does what we want, and it's a good fallback. If you don't want to have to deal with conditionals about whether is defined property supported, is defined getter supported, there's this nice polyfill by Ellie Gray, which combines them so you can actually use object defined property and it will work even in those that don't support it and only support that kind of getters. So you actually can use a polyfill in your polyfill. It's so meta. A problem with IE8 is that even though it supports successors, it only supports them on DOM elements. So if you need to do something else that's not related with DOM elements, you're kind of screwed. And also, if that wasn't enough, old IE thinks that properties and attributes are the same. So essentially, let's remember the case I showed before. When the placeholder property gets, somebody tries to read the placeholder property, we call getAttribute and we return the attribute. But what if the placeholder attribute is essentially the same as the placeholder property, like what old IE thinks? We try to read the placeholder property, so we try to read the placeholder property because attributes and properties are the same for old IE. So what does this give us? It gives us infinite recursion. So it's that horrible. We will actually make a script that's really slow, and it will return in a Stack Overflow. Also, IE8 has this other problem with defined property. If you try to use enumerable true, it will throw an error, which you can catch with this weird code, and just the solution to that is just to try to apply the accessor again without the enumerable true. Just set enumerable to false and try again. Also, the third thing we said is that new elements might get added, for example, through Ajax, through some script. So it's best if our polyfill doesn't break with them, and it's kind of simple to account for them. If we're modifying elements that are already supported, we can just add the methods to the corresponding prototype. You probably have heard that modifying host objects is evil, but in this case, you're not adding functions that weren't there. You're adding functions that should be there, and everyone, no matter how passionate they are about not modifying host objects, everyone agrees that this is a legit case of doing that. So you can even add a method to the element prototype, which is for every element, or to specific prototypes, for example, HTML input element. So in that case, it will be automatically in every new instance. But if you can't do that, for example, if you're making a polyfill for a new HTML5 element that doesn't have an interface in browsers that don't support it, you should use the DOM node inserted mutation event so that you do stuff when an element gets added that's of the type we're interested in. Of course, that bubbles too, so we can follow the same approach as we did for DOM attribute modified. We just register a general handler and we check if we're actually interested in that particular element that was added. Also, another thing you should keep in mind is minimizing dependencies. For example, libraries like jQuery might do your job quite easy. They might make your code a bit smaller, but when you're making a polyfill that requires jQuery, you're actually requiring that everyone who uses your polyfill also includes a library that's like so many kilobytes of code, especially if it's not gzipped. So just to add a small feature, some people will have to include a whole library if they're not using it already. And especially in polyfills, people want to use these new features so that they break free from libraries. So you should try to avoid it as much as possible, unless it really makes your job easier, unless your polyfill becomes 10 lines instead of 50 lines. But if it's like a difference, like for example, I've seen polyfills that use jQuery that were like 40 lines with jQuery, and there were like 55 without jQuery. Is that really worth it? Also, when you're making a polyfill, you might be tempted to support every possible browser, to support IE6 and IE7, and because you want people to use it, and even in big projects that require compatibility with very old browsers. But sometimes this makes your code huge, and it's not really needed to be that huge. And sometimes you can use the internal methods that a browser can have and take advantage of them and do what you want. For example, how many of you have heard about Match Media and what it does? Well, Match Media is a function, it's a global function, and it tests whether a document matches a certain media query. So some browsers already support it, and we decided to make a polyfill for those that don't. So how would you go with that polyfill? Most people would probably try to parse the media query expression and then check every condition separately to see if it actually matches. But we don't need to do that. It can be much smaller by just taking advantage of what the browser does with media queries, because the browser already has this functionality built in. So let's see how Paul Irish tackled this problem. He creates a new element, a new div, sets some styles and an ID that's unlikely to collide with another ID. And then it adds a style element with a media query inside that div. Style elements can be anywhere, so they don't have to be in the head, they can be anywhere in the document, so that's pretty valid and it works. And then it appends that element to the body. So let's think a bit about that. That style has a media query, and it gives that div a width of 42 pixels. What does that mean? That if the media query matches the document, that div will have a width of 42 pixels. If it doesn't, it will have another width. So now to check if that media query applies to this document, we only need to check if the offset width of that div is 42. So we actually took advantage of the built-in browser capabilities for checking media queries. And we didn't need to parse anything. So after we get that value, we clean up after ourselves, remove that div from the body, and we return the result. And because the spec is kind of weird and it requires us to return an object, even though it might seem stupid, and personally I don't agree with that much, we have to follow the spec and return an object literal like it's required with the result and the media query passed. Another example of taking advantage of the browser capabilities is trying to implement outer HTML. Outer HTML used to be a Microsoft proprietary thing, but it's now in the HTML5 spec, and eventually all browsers will implement it if they all don't already. So some people might actually try to parse the outer HTML and do something with that, or extract the inner HTML portion and then parse the tag portion, do something like that, but it's actually much easier. You first check if it's an XML document by checking the XML version property of the document. Yeah, that should be document, not doc. And if it's an XML document, we can't use inner HTML or anything like that, so we invoke the XML serializer and we serialize that node. If it's not an XML document, which is the most common case, we create a new element that we won't actually need, but it will help us in this case. And we append, we clone the node we care about getting its outer HTML. We pass the false parameters so that we don't clone the contents as well. Because think about it, we don't need to pass through to get the outer HTML, because we can just get inner HTML from that node, from the original nodes. So the only thing we care about is getting the HTML for the outer tag. So we just apply it to that dummy element. Then we replace, we get the inner HTML of the new element, we replace those that thing in the middle, and we add inner HTML, and then the inner HTML of the new element is what we want. It's the outer HTML that we wanted. We didn't need to do any parsing. We just used the browser capabilities. Also, this is sometimes an afterthought, but it shouldn't be. If you're making an HTML polyfill, you should keep accessibility in mind, because native elements have built-in area roles, or they can be focusable sometimes when the spec says they should be focusable, or they support some certain keyboard shortcuts, like, for example, a native slider supports being adjusted by the arrow keys. But so if you're actually implementing a slider yourself, you should try to fake these things too. You should make it focusable by tab index 0. You should add some area roles yourself and some area attributes, and you should support these keyboard shortcuts. I've seen so many sliders that can't be adjusted with a keyboard. It's so annoying. It's not even for people with disabilities. Everyone uses the keyboard. Also, like I said before, CSS polyfills are a big pain in the ass. If you're planning to start writing polyfills, don't start from CSS. Everything is hard with them. Parsing is hard because you need to parse the whole thing. Because if you try to go through the CSS object model, the browser will drop stuff it doesn't understand. So there's no point in doing that. We actually have to parse the whole CSS style sheet. Also, implementation is hard. At least implementation that's done unobtrusively. We almost always have to add extra elements and extra stuff, and it's always so intrusive. And reacting to changes is practically impossible. I mean, IE has this property change event, but other browsers don't. So we can't do anything about it. They're really hard, and that's why we don't have almost any CSS polyfills. Most of them are just API wrappers, like I said before, like functions that you call to do something, but that's not really a polyfill. So after you're done with the creative part, there comes the distribution part. Because you might be satisfied with your clever code, but you actually have to let other people know. and use it and help the community like it helped you. So the first part is making a minified version of your script, because people will actually end up using that. But you also have to include the original version so that people can study it and see what you did and how you did it and learn from you. But you should also include a minified version to be used for production. Then upload it to GitHub. It's like the common place these days for open source code. And the last step, but one of the most important, is to add it to the polyfills list. I think this is the most official polyfills list we currently have. It's not perfect, it's just a list in the GitHub wiki, and we should definitely do better. We need a polyfills database of some sort, but currently this is the most complete thing we have. So you can just edit this, it's a wiki, everyone can edit it and add your polyfill there. So now that this talk is nearing to its end, let's talk a bit about the people that have helped a lot in this field. First of all, Remy Sharp is the guy that actually thought of the word polyfill, and he's written many good polyfills that people actually use today. Also, Paul Iris has written loads of polyfills, and he also maintains this list of polyfills that I showed before. And I really admire Ellie Gray too. He's very young, but he's really talented. He's written so many polyfills, and his polyfills are always amazing. They're the least buggy polyfills I've ever seen, and he knows all these things about the inner workings of browsers. It's like crazy. But it's not just these guys. There are so many people that have helped by creating a polyfill or improving an existing polyfill. And this list is by no means exhaustive. There are so many more people. And these people have spent their time and energy just to help all of you, just to help the community. I think they deserve a loud clap for that. And you can also do that. You can also help the community like it has helped you while developing something. You can write something. You can write a polyfill or help by writing a feature detection test for something that's considered undetectable. You can really make a difference. And that won't really help it will really help yourself and your day-to-day development. It will make your code more future-proof, but it will also help everyone. So go ahead and polyfill these gaps. Thank you.